Oh, here I am waking up now. Oh, yeah. So, we're going to look into Chapter 13, Section 1, Introduction to Functions of Several, that's more than one variable. So a lot of times things in the real world are functions of more than one variable. Easy examples: volume or surface area of a cylinder, right? Volume of the cylinder is pi times the radius squared times its height. So we got radius and height as variables. And the surface area is 2 times pi times the radius squared, that's the top and the bottom, and then 2 pi r times the height h, that's the area of the lateral surface. You could think of it as the circumference of the cylinder times its height, right? That's really just a big folded out rectangle. But so I mean, that's just an example. And maybe volume of a box, length times width times height, that's 3 variables. So a lot of things in the real world are functions of more than one variable. So let D, standing for domain, be a set of ordered pairs. That means it's a set of pairs in the xy plane. You can think of it like that. If there's a unique real number, f of xy, then f is a function of x and y. It has to be unique, because if f of xy could go to 2 different numbers, then it's not a function. So if there is a unique number f of xy, then f is a function of x and y. The set of values of f is called the range of f. And actually, if I'm going to call it range r, maybe I'll make it boldface and italicized, right? Nah, just boldface, that's good. X and y are called the independent variables, and if we let z equal f of xy, then z is the dependent variable. So, here's a question. Example 1. Find the domain and sketch. And let me add to that, find the domain, I'm going to say range. And sketch. Well, the domain of a function f of xy equals x squared plus y squared over 4, that doesn't really have any issues that we must be concerned with, because x squared plus y squared is a polynomial in 2 variables, and the domain of a polynomial function is all numbers. So the domain of this one is all numbers, but pause for a second and think about what the range of this might be. Resuming from that pause, I hope you realized that, well, if x and y are both squared, then neither can be negative. So the smallest possible value for f of xy would be 0 when x and y are both 0, sort of the origin. And if x and y grow continually, then there is no largest value. So the range of this, the domain is all real numbers, or the entire xy plane. The range is a set of values z going between 0, including 0, and infinity. And the sketch, well, this particular animal is an elliptical, although this one is a circular paraboloid. And the domain is the entire xy plane, and that might be a new concept for you. So here's a picture. Just disappeared on me. There's the picture of a paraboloid. Let me move it up a little bit, and I can expand it and make it a little bit bigger. And here's the cool thing about it. I can move it around like this. So here's me looking straight down on it. Notice at 0, 0, right, is the very bottom point. And if you look at the way the z-axis is labeled here, you can see that the bottom point is 0. So the range is from 0 to infinity. Now, this doesn't really show up as infinity, but the fact that it keeps going up and up and up and up and up and up as x and y get larger should indicate to you that that is the case.